Hey Elizabeth, I have your first attempt on your quiz here. So I'm going to make a video real quick, just kind of going over the ones that you missed, and I also am going to attach two of my algebra videos. One covers most of the multiplication properties, or all the multiplication properties. The other one covers all the quotient properties, and then also just kind of puts it all together. So that's what this lesson has done. It's putting all of those rules for exponents together, and there are a lot of them. So the first question you missed was the one I have pulled up here, and it's asking which rules are going to be used. So we definitely see negative exponents, so that's going to be used. We have quotient of powers because we do have that fraction bar, so we have division. And then the one that also should have been checked was a power to a power. So anytime you have a parenthesis with an exponent and then another exponent attached on the outside, that is power to a power or power of a power. You chose power of a product. We don't actually have this one. This means I would be multiplying two things together, and then there would be an exponent on the outside of that. So we don't have that one, and it could have just been that you got those two rules mixed up. Okay, so let's check this out. This is, I know that they lead you up to working on problems like this, but wow, there's a lot going on here. And so I tell students, you can do it a couple different ways. You can apply that giant squared that's outside to everything, top and bottom. You can try to clean up what's inside first, top and bottom, and then apply that giant squared to everything. It just kind of is your preference. So I'm going to go ahead, let's see, which way do I want to do this? I'm going to go ahead and clean up inside first. All of my negative exponents need to move. Remember that when you have an exponent that's negative, it kind of sends it into the bottom or it sends it back up top. So the first thing I'm going to actually do is rewrite this expression with all positive exponents, and I'll explain what I've written in a second. Okay, so things that had positive exponents stayed put. All of those pieces stayed put. If it was in the numerator, it's still in the numerator. If it was in the denominator, it's still in the denominator. Now, the other three pieces that moved to the bottom, and now it's a positive power. This moved to the bottom, now it's a positive exponent, and that moved to the top, and now it's a positive exponent. Now, I cannot forget, everything is still being squared. Okay, now I'm going to simplify even further. 4 squared is 16 y squared over 2 to the third power. That's 2 times 2 times 2. That's 8. And that's, sorry, I don't know what happened there. That's supposed to be a 4. So now x to the third, x to the fourth. I can use the multiplication property that says I'm going to add those two exponents together. So that's x to the 7th. And then y to the 6th. And I am still going to clean things up. So what else can I clean up? Well, 16 over 8 is actually 16 divided by 8. That's actually 2. So I can put a 2 back up top. And I have a y squared on top and a y to the 6 on the bottom. 2 minus 6 is negative 4. So that's going to put the y's in the bottom. So now I have x to the 7th, y to the 4th. In the bottom, and again, I should have written that there. Everything is still being squared. Now I have everything cleaned up. So now let's go ahead and use that power to a power rule. Everything gets squared. So 2 squared is 4. X to the 7th squared, I'm going to multiply those two powers. That's to the 14th. And y to the 4th squared is y to the 8th. So power to a power, we multiply. So there we go, 4 over x to the 14th, y to the 8th. Now that's a lot. Now, some students like to just square everything and then clean up, and I'll do some examples where I do that as well, and you can kind of pick what works for you. But I did a lot of cleaning up until I actually applied that power outside. Now it looks like on these you maybe just didn't answer, so you might have missed a few or thought this is too hard, I don't want to do this yet. Rainey used the steps below to evaluate the expression when x equals -1 and y equals 2. where did she make her first error? And it wasn't until step 4. So let's see, what did she do? Substitute it in, so that's x, that's y, there's x, there's y. That looks good. Then you have to try to figure out what this girl did. Okay, so, she got rid of all the negative exponents. You can see all of these exponents now are positive. So she simplified inside the parentheses. It looks like this went up top here. That stayed. So I'm going to take care of that. That takes care of that. This went to the bottom because it's negative. So there it is. This went to the bottom because it's negative. There it is. And the 2 stayed put. So there's the 2. So that all looks good. And then what did we do? Why do we have a 2 to the second over a 2? Oh, okay, so then it looks like, let's see if I can erase. Nope, I have to get my little eraser here. Then it looks like from the left side to the right side, this 2 stayed put, and these 2's, they did the power, the quotient rule, where the quotient rule says that if you are dividing like bases, you subtract exponents. So 4 minus 2 is 2. So that's where this 2 to the second came from. And that's still there. And then here we have negative 1 to the 4th and negative 1 to the 3rd. When we're multiplying like bases, we add exponents. 4 plus 3 is 7. Then everything got the cube. So it looks like they'd actually cleaned up inside, similar to what I had done on that last example. So everything gets that negative 3rd power. So power to a power tells me I multiply. 2 to the 2 now to the negative 3rd. 2 times negative 3 is negative 6. That's good. 2 to the 1st. Remember, there's like an implied 1 there, and you can't see what I'm writing because that red line's in the way. This is actually 2 to the 1st. So 1 times negative 3 is negative 3, and 7 times negative 3 is negative 21. So far, everything is correct. Now use reciprocals to find the value. So the 2 to the negative 6 came down here. Ooh, this needed to go up top because it has a negative exponent, and this needed to go up top because it has a negative. No, it doesn't. Just kidding. Oh yeah, it did. Okay, sorry. So it looks like this moved to the bottom. This term moved to the bottom here correctly. The exponent became positive, but these 2 pieces should have moved up top, and they did not move up top, and the exponent just got changed to positive. So that is incorrect. There's where the error is. And that's a lot to go through just to find the error, but there it was. Selena and Drake are evaluating those expressions. Selena's work, Drake's work. We got a positive half and a negative half. Who is correct and why? So if we look at Selena's work, let's see, she cleans up inside first. So we have r to the 1st on top and an r squared on the bottom, and 1 minus 2 is negative 1. Negative 2, we have to be careful with exponents and subtracting. You have to subtract. Negative 2 minus negative 3, I'm subtracting these exponents, is positive 1, so that's good. Then everything gets the negative 1 power. Negative 1 times negative 1 is a positive 1. Negative 1 times 1 would be a negative 1, so that's why it moves to the bottom. So we get r to the 1st over s to the 1st. And now we're plugging in a negative 1 and a negative 2. Negative 1 over negative 2 is positive 1/2, so that's good. What did Drake do? Drake plugged in the numbers first. Plugged in negative 1 and negative 2 first. And then what did Drake do? Switched things to get positive exponents. Oh, okay, so that stays put, and it looks like Drake swapped these 2 things, right, to make the exponents positive. Correctly did that. And then negative 2 to the 3rd power. That's negative 2 times negative 2 times negative 2. That's a negative 8. But then if I also multiply it by a negative 1, should have gotten a positive 8 there. Negative 2 squared is positive 4 times the negative 1 squared, which is 1. We do get positive 4 there. And then everything gets the negative exponent, so that's why things switch. Remember that negative 1 is like taking the reciprocal because you're really dividing by that fraction. So that would have been correct. So then there's the error. That 8 should have been positive, which would have given a positive here and a positive there. So hopefully Selena was correct. Selena is correct because she simplified correctly and then evaluated correctly after substituting the values for the variables. Drake is incorrect because he should have simplified first. We don't have to do that. You can substitute right away. So that reasoning is not valid. He just made an error in his work. Okay, what's the simplified form of the expression? Now let's do one where we give everything that cubed power first and then we clean it up. You might find that this is a little bit easier. So everything gets that power of 3, and because it's a power to a power, we're multiplying. So x to the negative 9th, negative 3 times 3. Y to the 6th, 2 times 6. X to the 12th, y to the 18th. And now I'm just going to use the quotient rule. I'm going to subtract next. Negative 9 minus 12. Negative 9 minus 12 is negative 21. Because it's a negative, it's going to go into the bottom and become positive. This is weird how this is like erasing some of my work. And 6 minus 18, that's negative 12. And because it's negative, then it has to move to the bottom, y to the 12th. And when I don't have anything in the numerator, I have to put a 1. So there you go. And number 9. Let's go ahead and apply those powers. I can't clean up anything inside, so let's go ahead and apply that product to a power rule. So that's going to be p to the negative 8th and q to the negative 20th times p to the positive 8th and q to the negative 10th. So now really this is all multiplication. I could put dots everywhere. We're multiplying everything. And so we can add exponents on like bases. And negative 8 plus 8 is 0, and anything to the 0 power is 1, so those two kind of cancel each other out. Then we get q to the negative 20th times q to the negative 10th, which is q to the negative 30th. And so now I have to use the reciprocal to make that exponent positive. Remember, it really means you're dividing by q 30 times. So there we go. And question 10, look at these steps. Where's the error? Hopefully it's early, right? We have to work through all of it. Okay, so what the hardest part in these is just trying to determine what did they do. It looks like subtract the exponents of powers with like bases. Okay, so 3 minus negative 3 is 6. That works. Negative 2 minus negative 3. That's negative 2 plus 3. That is 1. They did get y to the first. And the 2 stays in the bottom. Okay, we didn't do anything with that because there's no coefficient up top where I could try to cancel or reduce. Apply the power of a product rule. So everything gets the negative 2 power. So x to the negative 12th, that's good. Y to the negative 2nd, that's good. 2 to the negative 2nd, that's good. Write negative exponents as reciprocals using positive exponents. So that's where you send things from the numerator to the denominator and from the denominator back to the numerator, and that's the error. Everything here should switch. Both of those should go to the bottom, and this one should go to the top, and you can see it did not go to the top. It got left in the bottom, so step 3 is where the error is. These are a lot. These are really complicated. These are like the hardest of the hard of all of these. So in my videos that I send you that are actually from my algebra lessons, I start pretty simple, and so it might be a good idea to kind of just watch them. If you want to take some notes down, you can. And then let me know if you have any other questions before you go on.